Our next lesson is about graphing linear equations. So the first question you might be asking is, what is a linear equation? First thing I want to tell you is this word is not pronounced linear, it's pronounced linear. So a linear equation, some of you might be able to guess, is an equation whose graph is a line. So an equation whose graph is a line. So we're going to start with a few examples that don't even involve graphing. The first thing I'm going to ask you is to tell if a point is a solution to a linear equation. So I'm going to ask you, is the point, or is the ordered pair a solution to the equation negative x plus 2y equals 8? And you're going to answer yes or no. So just a side note, an ordered pair, you hopefully remember that term from previous classes. You're going to see two things in parentheses, two numbers in parentheses. The first number is going to be your x value. The second number is going to be your y value. So let's start with some examples. So my first example, I have 2, 3. So remember, 2 is the x, 3 is the y. The way that we can find out if it's a solution is by substituting these two values in for x and y. So I have negative 2 plus 2 times 3 equals 8. All I'm doing is I'm taking my original equation, substituting in values for x and y. When I do that, I get negative 2 plus 6 equals 8. Negative 2 plus 6 is positive 4. That one does not work out, so my answer for this is going to be no. Make sure that you're answering the question properly. They ask you, is the ordered pair a solution? You say yes or no. So then we're going to do the same thing for part B and C. For B, I have negative 2, and actually, if I have a negative that I'm going to put in for that x, in the end, it will become positive. What's going to happen is it's going to become 2 plus 6 equals 8. That actually is true. I get 8 equals 8. So I'm happy there. That's going to be a yes. I do the same thing for my part C. And I'll find out that when I do that, I'm actually not going to get what I want. I'm going to end up with 1 plus 8 equals 8. I can see right away that's not going to work. So that one, the answer is going to be no. For our next problem, we will actually be graphing. So I'm going to show you the first method for graphing. We actually have 3 different methods that we can use for graphing. For the first method, this one you probably in the future, once you get good at the other 2, you're not going to use this one as often. But it's still an important one to know for when you get to nonlinear equations that are going to be a little bit harder. So we have graph 2x plus y equals 2. This equation is in what we call standard form. And to make it easier on yourself, I would recommend that you rewrite it by solving for y. So when you do that, you would subtract 2x from both sides and get y equals 2 minus 2x. So what we can do then is we can make what's called a t-chart. With a t-chart, what we're going to do is we're going to put in values for x, and then we're going to find what y is. So I always like to do general values for x. I always like to start with negative 2 and then go all the way up to positive 2. These are the ones that usually work the best. If you find other values that you like better, that's fine, but make sure you use at least one negative, at least one positive, and a 0 in there. Those are always the best ones to use. So I, on the side, have a grid. I would recommend that you use graph paper for this type of thing. If you don't have graph paper right now, that's fine. It doesn't have to be perfect, but just do the best that you can. So I'm going to go ahead and draw a line, and you can see it. I don't have a ruler, so it's not perfect. If you have a ruler, yours will hopefully look better than mine. So I'm going to go along these lines here. And each of these squares I'm going to use to represent 1. And since I'm doing it on the iPad, they look very, very imperfect, unfortunately. Hopefully yours look better than mine. So you're going to label each of these. If you want, you can label them all. Or if you say, well, labeling them all is kind of a pain, what you can actually do is you can just label one on the x-axis. That's this part that goes straight across, left to right. And you can label one on the y-axis. That's the part that goes up and down. So if you want to just choose one value to label, that's fine. That just shows that we are spacing each of these squares out by 1. So each of these squares represents 1. So now what you're going to do is you're going to actually do the graph. And we're going to start by finding out what the y is for each x value. So I'm going to take my equation, y equals 2 minus 2x, and I'm going to substitute in the x that I get for each one. So I end up getting y equals 2 plus 4, which gives me y equals 6. So that's my first point. So now I can go ahead and plot the point negative 2, 6. If you want, you can actually rewrite this as negative 2, 6 off on the side. You do not have to, though. That's just extra work. So we're going to plot the point negative 2, 6. What that means is we started our origin, that's this point 0, 0. We're going to go left to negative 2, and then we're going to go up 1, 2, 3, 4, 5, 6. So you do not need to draw those little points that I just drew. The only thing that you need is this one point up here. That is the one that you want, negative 2, 6. So now you're going to follow the same process for everything else. Some of you will be able to do this without writing out every step. That's fine if you can do that. If you have trouble doing that, that's also okay. Just do the best that you can on these. When you do this, you get 2 plus 2 equals, which is going to be equal to 4. We get a point at negative 1, 4. So for that one, you go to the left 1, you go up 1, 2, 3, 4, then draw your next point. You do the same process for 0, 1, and 2. So I'm going to write these off on the side. And I'm going to do it for every single point. So you'll find that as you do this, it does end up seeming a little bit tedious. It does end up seeming long. So in the future, you'll find other ways to plot these points, and most likely you're going to actually use the other ways to plot the points. You'll find that there's other things that you'll probably like better that will be easier and faster for you. And one thing I want to caution you about is if you get points that do not form a straight line, that means that you made a mistake, because all of these are linear equations. So if you find that you don't form a straight line, you probably are going to want to go back and make sure that you didn't make a huge mistake. I made a mistake actually right there, because I'll find out that if I go ahead and plot that, it's not going to work. So just be careful as you're doing these. It's easy to get off of to accidentally put your point on the wrong space. The main thing I ask you to do is if your points are not like perfect, if they're not a perfect line, for example, on this one at the 0, 2, it doesn't look perfect. It could be a lot better. I don't want you to just connect the dots. I want you to draw a line. So you're going to have, if you have a ruler, which I highly recommend, you just draw a line straight through them. Try to make it as straight as you can. And that's our line. Our next two examples are actually two special cases. So for number 3, you can draw a chart if you want to, but you'll find the same exact thing happens. So if x is -2, y will be -3. If x is -1, y will be -3. If x is 0, y is also -3. So you'll see that there is a pattern. No matter what you put in, you're going to always get y equals -3. If you want, you can go ahead and draw those points down there, and you'll find that you end up getting everything is at -3. So instead of doing this chart every time, that's not a necessary step. You can actually just remember that this is a straight horizontal line at -3. So this is a horizontal line. And what you're going to do is you're going to go on the y-axis, you go down to -3, that's where this point is right here that I'm drawing right now. So that's going to be at -3. So that's my recommendation, that when you see y equals something, you remember it's a horizontal line at whatever y equals. Now you might also be able to guess that if that for this one, every single value of x is going to be 2. It doesn't matter what you have for y, x will always be 2. So if you remember, this is the x-axis, that's the y-axis. The way that you can get this is to go over to x equals 2, and you'll find if you keep trying to draw points where x is 2, they're all going to be in a vertical line. So what you can do is you can just draw a vertical line at x equals 2. So that's a vertical line. So now, if you're in the CP math class, you can actually stop your video right now. You do not need to watch the next part. It's an honors only thing. It has to do with domain and range, which we haven't done in CP. So if you're honors, please keep watching. If you're CP, feel free to stop. Our next type of problem involves graphing a function that has a given domain. By the way, if they say graph the function, it's the same exact thing as graph the equation. The only difference is that now they have a domain. Sometimes they'll just tell you to graph the function though, and they won't give you a domain, which means it's going to be all real numbers. So in this case, we are going to only look at values where our x is less than or equal to 0. What that means is, if you think about our x-axis, if you look on that, our x equals 0 occurs actually at the y-axis, which is this part right here. That's our y-axis. So what you're going to do is you're going to look, everything that you're going to have on this line is going to be to the left of the blue part that I just wrote, which is the left of the y-axis. So it's important that when you do this, that you don't have anything to the right of the y-axis. So the way that you do this is by starting and making a t-chart again. Now, our big difference is our x values are only going to be 0 and things less than 0. So it's going to mostly be negatives. We're going to have 1 0 in there and then a bunch of negatives. So I'm going to start with 0. In addition to that, I'm going to choose only, I can do, if I want to, I can choose -1, -2, -3, but that would be complicated for the odd numbers because then I'm going to get a fraction. So I'm actually going to choose only evens to make my life a little easier. So I'm going to do -2, -4, -6, and -8. Notice how I put these in numerical order from least to greatest. If you forget and you do the 0 first, that's fine. But in this case, I did put them in order nicely. So now you're going to follow the steps you did in the previous problem in number 2. You're going to take this equation, y equals 1/2 x minus 1, and substitute in all of those x values. And when you do that, you're going to find for -8, you end up getting for x equals -8, you're going to end up getting y equals -5. When x equals -6, you're going to end up getting y equals -4. And when x is -4, if you substitute that in, you will end up getting -3. When x is -2, you'll end up getting -2. And when x is 0, you will end up getting -1. If you're not sure how I got those, I would recommend maybe working out these equations just on your own. You can check and make sure everything looks good. So I'm going to go ahead and graph it. I'm actually going to start with x equals 0 because that one's easier to look at, so it's easier to find on your graph. So I'm going to put a point at 0, -1. Then I'm going to put my point at -2, -2. Same thing with -4, -3. And then -6, -4. And then finally -8, -5. Now, if that last point goes off of your graph, or the last 2 points go off your graph, that's fine. Try to get as many as you can on there. So now, the key thing you need to remember is that we're only looking at values where x is less than or equal to 0. So do not draw a line through the y-axis, or you're going to get something that doesn't work and you're going to have to erase. So we're actually going to draw what's called a ray. Now, a ray it's kind of like an arrow, except that it has an endpoint on one end. So we're going to start at 0, where x is 0. Then we're going to draw our line, our ray, through these points. And it's going to look like that. So now, we're almost done. The only thing we need to do now is find our range. Remember that the range is the possible y values. And if you look at this, look at what's in blue. In blue, I have my ray, and it's only at values that are below here. So my y values are all at this green line and below. And actually, that green line is at y equals -1. So the way that we're going to say our range is that it's going to be less than or equal to -1.